Dear students of class 10, in this video we will learn to establish the relationship between the zeros and the coefficients of a quadratic polynomial. Let alpha and beta are the zeros of a quadratic polynomial of variable x, and we know that the standard form of a quadratic polynomial is ax square plus bx plus c, where a must not be equal to 0. Then by the factor theorem we can say that the x minus alpha and x minus beta are the factors of px. Now the given quadratic polynomial can be factorized as k into x minus alpha into x minus beta, where k is a constant, and as we proceed we get finally kx square minus k into alpha plus beta into x plus k into alpha beta. On comparing the coefficients of like powers of x on both sides, we get k equal to a minus k into alpha plus beta equal to b and k alpha beta equal to c. As k equal to a, then we can write minus a into alpha plus beta equal to b and a into alpha beta equal to c. And finally we get alpha plus beta equal to minus b by a and alpha into beta as c by a. Now dear students, we can say that the sum of zeros will be equal to minus the coefficient of x divided by the coefficient of x square, and similarly the product of zeros will be equal to the constant term divided by the coefficient of x square. So for a quadratic polynomial, alpha plus beta is equal to minus b by a and alpha beta equal to c by a. If alpha plus beta are the zeros of a quadratic polynomial, then it can be expressed as px equal to x square minus alpha plus beta, that is sum of zeros, into x plus alpha beta, that is the product of zeros. Now we can solve the questions of exercise 2.2 of our NCERT book. Question number 1. Find the zeros of the following quadratic polynomials and verify the relationship between the zero and the coefficients. Let us try to solve the first question. Here we have the quadratic polynomial x square minus 2x minus 8. To find its zero first, let us factorize this by the method of splitting of middle term, you know very well, and we get the factor as x minus 4 and x plus 2. In order to find its zero, let us equalize the factors as 0, and we get two zeros of this polynomial, that is alpha equal to 4 and beta equal to minus 2. After getting the zeros of the polynomial, now let us verify the relationship between its zero and the coefficients. Here we have for sum of zeros, that is alpha plus beta becomes 2 divided by 1, and that can be correlated as minus coefficient of x divided by the coefficient of x square. Similarly for the product of zeros, that is alpha into beta, that will be equal to minus 8 divided by 1, you can see on the screen, and that can be correlated as constant term divided by the coefficient of x square. So dear student, we can verify the relationship between 0 and its coefficients in this way. In second question, we have to find the polynomial for which the sum and the product of its zeros are given for each. So let us find for number 1. Let alpha and beta be the zeros of the required polynomial px. Then we have alpha plus beta, that is the sum of zeros, as 1 by 4, and alpha into beta, that is the product of zeros, as minus 1. Dear students, we know that the required polynomial should be as in the form of x square minus under the bracket alpha plus beta into x plus alpha beta. So we can write x square minus 1 by 4 at the place of alpha plus beta into x plus minus 1 at the place of alpha beta. And we get the polynomial as x square minus x divided by 4 minus 1. And finally, the required polynomial can be framed as 4x square minus x minus 4. Dear students, now you can solve the rest of the questions of this exercise in the same manner. In the next video, we will learn about the division algorithm for the polynomials. Thanks for your time.